So myself, I am Laszlo Varga, and I'm the lead researcher and analyst at Nimdzi Insights. And your co-host today will be Philippe Gelin from the European Commission. And before we start the conference, I would like to go through a few housekeeping items. All right. First of all, we would like to keep these sessions more in a webinar format, but we'd love you to ask questions that we can answer throughout the conference. You will notice that in your application, you have a Slido button, a green circle with an S in it. And in Slido, you can ask all the questions during the sessions and even at the very end of the conference. We'll be very happy to answer them for you. This session, as I mentioned, is recorded, and the project website, which you can access through the QR link right here on the screen, will include the link to the YouTube recording, where you can watch anything that you have missed later, as well as we'll also post the slide decks used in at this conference at the same YouTube post. Next, I would like to very quickly talk about the agenda. We will speak with first, Philippe Gelin will start with an introduction, and then I will hand over the word to Josef Kubovsky, our Chief Executive Officer at Nimdzi Insights. And after about 20 minutes, we will move on to an executive summary from the market study on language technologies, as was commissioned by the European Commission. Then we will take a short break, and we'll continue with breakout sessions with specific language technology categories, large language models and generative AI, foundation models, followed by text-based language technologies and speech-based language technologies. Then, even though after each of the sessions, we will listen to or read your questions and answer them, we'll have general questions and answers as well as a closing. And we plan to close the conference at 12. Moving on, I will hand over the word to Philippe Gelin for an introduction.
Thank you, Laszlo, and welcome to everybody. It has been, it is, and it will be for a while a revolution. Call it data, call it information, digital or AI revolution. One thing is certain, the digital world is changing amazingly quickly. And this is not at least because of language technology, the topic of today. The knowledge shared today will guide our future effort to remove language barrier still present in our internal market and to boost European competitiveness. Do you know that close to 200 million Europeans do not speak a second language? Do you know that 300 million Europeans will always select their own language to buy over internet? The latest language technology offers the possibility to cut these costs, reduce the language barriers, and increase European trade by hundreds of billions. But to grasp this opportunity, it's essential that this technology works equally well in all European languages and are available for all Europeans. The European Commission has already proposed several actions to create optimal conditions for developing and deploying a truly European language technology. So let me start with some of the important technology that we are offering directly to the SME to support the access to the internal market. Over the last years, the Commission has supported the SME by providing free access to a range of tools and services induced by our own need and in-house machine translation tools, but also offering transcription, pseudo-anonymization, and the like. Direct support for SMEs also include a comprehensive set of tools for automatic website translation. Our goal is to enable SME wherever they are and whatever they do to benefit from the untapped potential of single market, fostering great integration and competitiveness across Europe. Then there is also data. As you know, data is the all of AI, and it's imperative that data produced in Europe benefit European citizens and businesses. We need to facilitate the availability of language data for the benefit of our economy. The way to do it is by establishing language data space. The data spaces are a secure marketplace combining governance and infrastructure, generating trust, which is essential for facilitating data exchange and valorization. They ensure the valuable data can be shared and utilized across different sectors and regions while fully respecting privacy and accountability. The language data space fosters the creation, sharing, and reuse of multilingual and multimodal datasets, supporting the development of culturally aware digital solutions in Europe. The first prototype of the language data space has been unveiled in March this year, and by the end of the year, it will be fully functional. But in addition to the data space, we also have set up the Alliance for Language Technology, EDIC. EDIC stands for European Digital Infrastructure Consortium. It's a new legal instrument federating the effort of member states in key technological areas. It aims at ensuring that the investment of the member state and at European level all go in the same direction. This ALTEDIC first priority is the availability of language data. This initiative underscores the EU dedication to ensure autonomy and competitiveness in the rapid evolving AI landscape. Co-financed by 17 member states and one region, with an additional 8 member states as observers, and supported by the European Commission, this structure will build a robust European ecosystem and significantly enhance our capacity in language technology. The ALTEDIC will have a key function in supporting the development of large language models in Europe and their adaptation to the specific of our market and language, but also the deployment of this technology across the different member states and the different economic actors. All these efforts are critical in helping SMEs reaching and engaging with more stakeholders across Europe in all its linguistic diversity. They are essential for making Europe competitive in the area of artificial intelligence. So you see, this is what is at stake in this discussion, in this meeting or this workshop, when we will present really what is the market status of language technology. Thank you all for being here. I look forward for the insight discussion and valuable exchange that will undoubtedly help change. Thank you.
Thank you, Philippe. And
Yes.
thank you. And I will hand it over to Josef Kubovsky, our CEO. And Josef will introduce us to the world of language technologies and their benefits throughout industries, not just localization, but everywhere else in the world. Josef, please take it away.
Thank you. Thank you, Laszlo. Thank you, Philippe, for a warm introduction and warming the audience up. Welcome. Welcome, everyone, to the Language Technology Landscape Conference in 2025. This diverse gathering truly reflects the spirits of multilingual cooperation, which defines our mission. I hope you feel as excited as I am to be here. Before we dive in, I want to express my heartfelt gratitude to the stakeholders who made this conference and the project behind it possible. This event not only marks our annual conference, but also nearing conclusion of the remarkable 2-year collaboration project. Over the past 2 years, Nimdzi Insights have worked with the European Commission on a comprehensive market study on the language technology. Together, we've been mapping the language technology landscape, analyzing the trends, assessing Europe's position in the global arena. As we approach the finish line of this project, it's fitting to take a moment to thank everyone involved in this journey. So first, special thanks to the European Commission, DG Connect, for championing this initiative and hosting us. Our host today, Philippe Gelin, has been driving force, ensuring that language tech stays high on the EU's digital agenda. And of course, a big thank you to my team, to Nimdzi Insights, especially led by the lead analyst, Laszlo Varga, and his research team, for the countless hours spent on gathering data and the insights. I also want to acknowledge the many organizations and individuals who contributed, from the companies who responded to our survey, to the language and technology professionals who share their on-the-ground experience. Your input has been invaluable. So over the past 2 years, our market study on the language technology has been mapping the current language technology landscape and providing an overview of the most relevant market trends. We're excited to share some highlights of what we found. In short, The language technology market is driven and full of promise. It's a vital sector addressing the myriad language challenges that business, governments, and citizens face in our multilingual world. And importantly, the study shines a light on Europe's role, how influential and uncompetitive Europe actors are, and how large the development potential in the global language market. One of the first questions we tackled was what exactly comprises the language technology market? It's a web of interconnected technologies. By contrast, we see explosive growth in the newer segments, large language models, the foundational AI models capable of understanding and generating human-like text have quickly became 6.5 to 9 billion US dollars market on their own. This category includes not just general large language models. In other words, generative AI for the content is already multi-billion-dollar industry, riding the wave of interest in creating marketing copy, product description, and even new articles in many languages at once. At the same time, large language models are also productivity enhancers in many walks of business, from writing sales emails to assisting coding or customer service AI agents and language tutors. What about machine translation, you ask? Machine translation, the MT market reached around 2.5 billion US dollars in 2024, growing by 30% in that year alone. It's important to note that machine translation is also increasingly embedded inside the other solution, translation management platforms or large language model application or SaaS platforms. In our industry, we often so overlap. Lines between categories are blurring as technologies converge. The overall language technology landscape is expanding. From management system to AI models, speech recognition to terminology tools, each segment plays a role in enabling global communication. And crucially, these technologies don't exist in isolation. They interconnect and build on each other. For example, a large language model can be used to improve machine translation quality. A speech-to-text system feeds into translation engine, which then uses text-to-speech to outbound another language, a complex chain that spans multiple technology segments. Understanding this ecosystem was a goal of our study in the global perspective. So we present in the last year's conference, we aimed at untangling the web of interconnected language technologies. What did we learn about Europe's position? The study puts special emphasis on the European market. We wanted to find out how Europe stacks up globally, where we are strong and where we need to catch up. The findings are encouraging. Europe is as long as being a powerhouse in the language industry. In fact, Europe currently accounts for about 35% of the global language service market. It's shrinking in share, but it's making the world's second largest region in our industry after the US. This isn't surprising given Europe's culture and linguistic diversity. Demand for translation, interpreting, and localization here is immense. On the technology front, Europe boasts world-class companies in several niches. For instance, many leading translation management systems and CAT tools providers are European. Some of the most widely used translation management and productivity tools were born and built in Europe. In machine translation, European research labs and companies from DeepL in Germany to Tilde in the Baltics are producing cutting-edge machine translation systems. And Europe has tradition of collaborative projects such as European Language Grid, ELG, and others that foster innovation in language AI for all EU languages. And now comes LDS, Alptic, AI factories, Invest AI, Apply AI strategies, and so forth. However, the study also highlights challenges and gaps. In certain fast-moving areas, notably in the large language models and AI infrastructure, Europe is far from leading. That space is big tech dominated by few giant players, mostly based in the US, who have the vast data and computational resources to develop frontier models. And easier, not better, access to data. Also, VC culture and risk tolerance helps. We see that while Europe has top academic talent and some startups working on the large language models, the scale of investment lags behind. This finding underscores why EU strategic focus on digital sovereignty is so important. Similarly, in voice technologies, many core platforms are driven by big global companies. So one takeaway is that Europe must continue to support these innovators if we want to be competitive across all areas of language technology. On a positive note, the development potential remains huge. Many European companies in our sector are SMEs, agile, specialized, and hopefully innovative. With the right support, they can scale up and compete globally. That study's overall goal was to raise awareness about the potential of language technology and inform stakeholders and investors with an accurate, up-to-date view of the market needs and trends. To sum up, the study's highlights in plain language. Language technology is driving economic sector and a pillar of the Europeans' digital future. It delivers economic value measured in market size, growth, jobs, and cultural value, enabling multilingual communication, preserving linguistic diversity, and making technology accessible to all Europeans in their native languages. These findings in numbers equip us with evidence to advocate for our field. They also guide us on where to invest and what to watch for next. I only have a few minutes for the keynote, so the study is extensive, and my colleague Laszlo will be speaking about more details in the data and the wealth of data. So I encourage everyone to read the entire study later on. I want to speak a little bit about, with machine translation, AI copywriters and speech boots improving daily, it's natural to ask, what is the role of human linguists and translators in the future? Let me say, their role is paramount. In fact, the more advanced our tools become, the more we need skilled humans to guide, refine, and make the most of these tools. Why? Because our language is initially human. Language carries nuances, emotion, cultural context, and values. Our technology, as impressive as it is, does not understand meaning and context the way humans do. It predicts patterns. We live the language. The machine might give perfectly fluent sentence, but only a human can judge if that sentence truly conveys the intent message, or if it might subtly offend in other culture. Human translators, editors, terminologists, interpreters, all the language professionals provide the quality assurance, cultural adaptation, and ethical judgment that technology alone cannot. We've seen dynamic before. In the early days of machine translation, people feared translators would replace. Instead, the translators became post-editors and language consultants, doubling and tripling their productivity by teaming up with machine translation. Today, with AI content generators, we see writers become editors, fact-checkers of AI outputs. New technologies emerge, but they coexist with the old ones. Each leap forward in tech has its in practice, created new opportunities for professionals rather than simply eliminating the jobs. My colleague, industry veteran Renato Benignato, often reminds us of language industry is not zero-sum game. He recently noted that AI and automation created new opportunities, just as every technological leap has done before. And I completely agree with him on this. There is another human element that technology can't replicate: passion. The passion of translator who deeply cares that poem evokes the same feeling in another language. The passion of a speech therapist using ISR to help someone with a speech impairment, knowing when the tool is off and gently correcting it. Or the cultural knowledge a localizer brings when adapting a market campaign, understanding what visual or phrases will resonate or flow in their locale. These human contributions are invisible in the code. Technology doesn't make our work easier per se. It often just makes it different. More tools can even mean more complexity initially, but with time, we streamline them and our efficient leaps. The key point here is people must steer the technology. To all language professionals listening, your expertise is valuable and is irreplaceable. The tools being developed are not meant to replace you, but not kill you. Together, humans and an AI can produce results neither could achieve alone. This synergy is the future of. We approach the end of this talk, and I want to leave you with an optimistic vision. If there's one thing to take away today, is that the future of language technology is bright, and it's in our hands to shape. We have enormous opportunity ahead of us. The research from our market study and others shows that an industry powered by language technology will continue to grow and thrive the coming years. Some analysis project the language services and technology market could reach nearly $95 billion within the next 5 years. And beyond the financials, the importance of what we will only increase is the world becomes more interconnected. Nimdzi Insights has recently introduced the concept of the language industry curve. It's a forward-looking view tracking our industry's evolution over the past 40 years and predicting its trajectory into the future. If I could show one visual, it would be that curve, an upward line demonstrating how our industry has steadily expanded, adapted, and reinvented itself a decade after decade. It's a reminder that we've been here before with another tech revolutions, and each time we grew. From the first CAT tools in the 1990s to the statistical MT boom in the 2000s, the neural MT in the 2010s, and now language models in 2020s. Every wave initially caused doubts and disruptions, but ultimately led to a bigger market and more demand for language solutions. The industry will become to grow. It will evolve, and those who adapt will find new ways to triumph. Those aren't just my words, they're the words of the leaders who've seen this play out. I'm confident that in 5, 10, 20 years, we'll look back at 2025 as an inflection point where language technology truly went mainstream, where multilingual AI become standard utility like electricity, and where we open a new frontiers for global collaboration. Imagine Europe where a world where no content, it's very limited by language, where a startup from a small country can instantly offer its product to 30 languages, reach markets worldwide, where a doctor in Poland can consult easily with a colleague in Portugal about a case, each speaking in their native language, but understanding each other through a device. where children can access educational videos in their mother tongue, even if it's spoken by only 100,000 people, because the AI can translate Khan Academy or Wikipedia content for them. This is the world where we are building. It's a world that fulfills the deep human aspiration to connect and understand one another. And it's hard not to be inspired by that. Of course, we have challenges to address, ensuring quality and trust, managing the impact on jobs, securing the data and privacy, and bridging the digital divide for smaller languages. But I see in this room and in this community a determination to tackle these challenges together. The very existence of a collaborative project between the European Commission and the industry experts, like the one we're wrapping up, demonstrates our shared commitment, shared mission across borders. It's not just a phrase, we live it. Europeans working with international partners, researchers teaming up across countries, public and private sectors in dialogue. This is how we solve big issues. So to everyone here, whether you are a policymaker, an engineer, a translator, a CEO, or a student, you have your role in this mission. Keep innovating, keep questioning, and keep collaborating. The fact that we speak different languages has been perceived as a barrier in the past. Now, thanks to what you all do, it's becoming a bridge. We are providing technology that can unite, not divide. I'd like to conclude with a simple thought. Language is what makes us human. Now is the time we're teaching machine to truly grasp it. It's grand endeavor. One of that requires the hand, our clever algorithms and strategies, and the heart, our human empathy and values. I'm optimistic because I see both present in this community. Together, we will ensure that the language technology landscape grows in a way that benefits all of humanity. Thank you very much for your attention. Let's continue to inspire and innovate together. Here's to multilingual future where everyone's voice is heard and understood.
Josef, thank you so much for your inspiring words. Appreciate it. And now we're moving on with the agenda, which means I have half an hour to discuss the language technology landscape as an executive summary. There's a lot to talk about. There was 2 years of research going into this conference, which will ultimately conclude with the study report, which will be published in the official 24 languages of the European Union. It has still a few hurdles to jump before crossing the finish line that Josef mentioned earlier. And I would like to very quickly acknowledge the fact that when this project started, ChatGPT was not out yet, which means there were many challenges that we faced in the initial stages of the research, especially when it came to categorization and understanding of language technologies. The interconnectedness of language technologies before models was essentially non-existent. They were purpose-built. And the new wave of AI has brought about a blurring of lines between the different categories of language technologies. That said, the team here at Nimdzi Insights, we mapped the landscape, the actors, what demand looks like, the market sizing exercise, as well as understanding and identifying trends and insights. And also, we gathered insights about how influential or competitive Europe is in the field, with the aim to raise awareness about language technologies and its potential. And of course, not just desktop research, but also we conducted 2 surveys last year and this year, also expert interviews, and Nimdzi's wide experts knowledge was used within the language technology and services arena as well. We are consultants and researchers in the language industry, which put us in an ideal place to conduct this research. Last year, we already had a conference similar to this one. That was an all-day conference. Today, we only have 3 hours, which means we will condense the presentation to the most important insights. And again, as mentioned, this conference recording will be published very similarly to last year's on the European Union's Digital EU channel. Let's start from here, the benefits of language technologies. And Josef, you mentioned essentially all of these. Individuals, communities, small, medium businesses or large enterprises, as well as public organizations and generally the economy relies on language technologies, often invisibly. We can say that ChatGPT changed that and brought language technologies to the front line, but the benefits are the same. Because number one, they enable multilingual communication. And through that, very specifically, international trade, which is especially important for the multilingual European Union. As you might know, the United States recently changed its official language to being English on a federal level even, which means Europe is heralding multilingualism to its fullest. And language technologies help lower the barriers when it comes to international trade. It's not to say that language technologies solve the problem, but they certainly help to lower those barriers so that any business at reasonable costs and efforts can offer their products across borders. In addition, language technologies enhance productivity. And traditionally, this has been the role of language technologies in the language industry. For translators or transcribers, the machine translation or speech recognition tools, speech-to-text tools, they have been instrumental over the past years. The new wave of language technologies, they enable new use cases. Would that be information retrieval, question answering, summarization, even software code creation, or support in customer support. That productivity enhancement has very profound implications on the future economies of every country, including that of Europe. Last but not least, language technologies can help protect linguistic diversity. What do I mean by that? Number one, many language technologies that are being developed, they're focused on English. English as a source language or English as a working language. You will notice that this conference is also in English. We will publish, of course, as I mentioned, in all European 24 language, EU 24 languages, the final report. That said, when individuals of non-English native language use language technologies, would that be ChatGPT or would that be machine translation engines, they will notice that, or they might notice that the performance of these tools are not the same across languages. And building language technologies that help bridge the gap between the gaps in these capabilities is really important. And so core principle in the European Union, linguistic diversity is something that is being heralded. To speak about specific benefits of language technologies, Josef also mentioned already, we conducted the research back in 2023, which resulted in the insight that 7 out of 10 users will always select their native language over English in e-commerce. That essentially means that no translation means no trade. So machine translation systems, in essence, provide alternatives to no translation. They're not necessarily alternatives to human translation, but they alleviate the gap between the user who does not speak the native English, the website's English language, and be able to understand the product, the service, and make purchasing decisions. And there are great European examples even of companies, even large enterprises that use machine translation and AI tools, language technologies in their communication with their customers. Would that be Booking.com or Zalando, IKEA, or SAP? As Josef also mentioned, Europe is a foundry of multilingualism, which means about 35% of the global language services and technology demand comes from Europe. Yes, it is shrinking to a certain degree, but we will see what happens in North America with a new administration in place there. Very important insight here is that language technologies, by now, especially machine translation, which supports cross-border trade, they are insignificant in cost compared to the benefits that come from trade and the opportunities that go opened to new customers and new markets. Separately, this specific study that we're conducting is part of a bigger project. Another part of this project was aimed at understanding the multilingualism of European websites. And here are some key insights from there that support the no translation equals no trade statement. We know that there are about 24 million small medium enterprises in Europe. The project led by Tilda, including IDC, Ogilvy, and ELDA, they found through a randomized sample of websites that, and it included more than 400 websites that they scraped and analyzed, that small and medium enterprises are far more likely to not have multilingual websites than large enterprises with more than 1,000 employees. Second, they also found that about 35% of websites in Europe, based on that sample, are bilingual, but only about 15% of them have content in 4 or more languages. That means there are great gaps in the multilingualism of European online presence. In addition, this study also conducted interviews with 122 companies, and those revealed the following insights. Number one, the most common reason for businesses to translate their website is to reach new markets, new customers, new revenue. Second, the main challenge is accuracy of automated website translations. So the better the machine translation engine is, the better it is for business, and the better it is for users to understand the product, the service, and make the decisions. Third, the most popular engine used in website machine translation services by enterprises is Google Translate, followed by Microsoft and Amazon's tools. That means knowing that many of these tools do not provide equal quality across languages and language pairs, there is a need to provide tools or to create them that create an equality between language pairs and accessibility to markets for enterprises. On the user side, the study also conducted a user behavior survey. And through surveying more than 4,000 individuals in 6 EU countries, they found that about 57% of users at least sometimes abandon a website if the preferred language of their choice is not available. In addition, 71% of the users will distrust websites with poor language quality, which means essentially that trust comes from quality. The study also looked at what machine translation engines are used by users. So website owners can translate their own websites, but of course users have the opportunity to use machine translation engines in their browsers or as a plugin. And they found that about 80% of users are ready to do so. And more importantly, 49% of them rated the quality as good, and only 4 of them said that the quality of machine translation engines were poor or very poor. And unsurprisingly, 95% of the users will turn to Google Translate when translating websites in their browsers. Which is to say, if Europe is to strive for sovereignty in language technologies and providing equitable access to language technologies across languages, there is work to be done. And that work is being done through the project that provided this report as well. Going back to the impact of language technologies, we also try to quantify what this benefit could look like, even in euro values. Our calculation found that while SMEs are adding about 53% of the value created in the European Union, if they were to use machine translation tools and language technologies for translating websites and accessing new markets within the European Union, that would create additional trade of about 360 billion. And indeed, for small and medium enterprises, the language divide, and specifically translation and localization costs using humans, are a high barrier to trade. 360 billion is a big number, but even bigger than that, the impact is the impact of productivity, specifically coming from tools such as large language models. And a McKinsey report estimated a global impact from which we calculate that the EU has somewhere around a 1 trillion euro economic opportunity with the new wave of AI tools. And again, very importantly, the underlying assumption behind the calculations of McKinsey and as well as this estimation is that the models the language technologies, they work and support all languages at the same quality level, which is currently, unfortunately, not the case. As I mentioned, one of the key challenges we faced in this research project was defining even what language technologies mean. Because more often than not, the words AI or generative AI or large language models, they are used interchangeably. And while large language models certainly do qualify as language technologies, some of AI doesn't. Generative AI, such as image generation or video generation, those are not language technologies per se, even though they might contain a component which translates the natural language input into instructions that actually create the image or the video, or music even. That said, to somewhat clear the confusion, we created what we call the language AI alphabet, and you can find this on our website. And this is a representation or a highlight of what we consider language technologies within the artificial intelligence space. And very importantly, large language models, which are a form of AI, they actually were born out of the traditional, by now traditional, neural machine translation paradigms. So even though large language models, ChatGPT brought AI into the forefront of public discourse over the past 2.5 years, actually, machine translation, if anybody has been using it since 2017, you have been using AI in your day-to-day life as well. Very similar to speech recognition or speech synthesis, they are also all AI tools. Essentially, AI is eating the world of technology, including language technology. The key insight here is the speed of improvement, which is to say progress is measured in weeks rather than months or years, or as I a few weeks ago said at the Alt-EDIC launch event, language technologies, specifically AI, is developing so fast that if you blink, you might have missed it. The chart on the right says that if you look into Archive, one of the largest depositories of research papers, papers relating to large language models have exponentially grown in numbers over the past years. And that's primarily thanks to the fact that large language models are not purpose-built models, but rather they give the impression and the opportunity to do multiple tasks at once. But AI feeds on data, and data is the new oil. And that has implications. Number one, language technology developers on the supply side, those that create language technologies, they realize that the higher quality the data, the more efficient, which means smaller, cheaper, and faster models to train and to run these models can be. And this is already seen, of course, when we look at the different even individual AI labs creating their models. They come in various shapes and sizes. The larger the model, the more capable overall it might be. But a smaller, cheaper model might be just as good at the specific tasks and for a specific company or a specific individual. And the more specific the data is to the client or domain or use case, the better the results are. On the buyer side, of course, on the demand side, enterprises, small or large, they require custom tailor-made solutions. And they have the data, their own previously translated segments, their own collected user behavior data, their own metadata about their content, and so forth, their own code repositories. And those need to be included in the AI systems and tools that they deploy on their own end. And language technologies on their own don't solve the biggest problems without human oversight. Importantly, where large enterprises typically have data and machine learning engineers, small, medium enterprises don't. And because large language models for customized solutions are not plug and play, very importantly, there is a need of support for small, medium enterprises to gain value through language technologies and AI, language AI in specific. A recent study by BCG found that about 74% of companies have not yet shown tangible value from the AI implementations. And that's a warning sign to say it's easy to play, it's easy to connect, it's easy to integrate, to create value through AI and language AI is not trivial at all. Next, about sovereignty. Clearly, we live in a world where, say, in the past few months, many global structures have been and are being challenged. Sovereignty in Europe is more important than ever. And while the EU strives for a single digital market, it needs to protect its sovereignty not just in defense, in intelligence, in energy, but also in language technology and language data. So safe, regulated AI and data governance are key to success, especially in the EU, where corporations are much more privacy and security minded. And so many of the key initiatives, the language data space, LLMs for EU through the Alt Edict, AI factories, or private investment incentives are really important to drive this kind of sovereignty forward. And being in control of the underlying infrastructures, technology architectures, and importantly, the data are critical to achieving the autonomy. We know that the US and China are, in a sense, leaders in AI development. Europe has catching up to do, and the study shows that Europe might be in the right path to achieving that, especially for European companies. But most of the numbers show a different picture. On the left, you will see investment data coming from the Stanford AI Index, which was just released a few days ago. We know that in the United States, there are discussions about hundreds of billions of dollars to be invested into AI data centers and generative AI, large language models, even discussions to open nuclear power plants. And Europe seems to be underrepresented, close to China in terms of private investments, but the United States outranks both those regions. But in reality, quantity matters more. The example on the right is from Llama 2, Meta's large language model family, which shows that more than 95% of the data used for the training was English and unknown. And unknown, actually, if you read the report or the paper, it says it's mainly software code, which means all the rest of the languages so important to Europe, starting with German, French, Swedish, Spanish, etc., they're seriously underrepresented in the training data, which means very likely these models out of the box, they will not be as potent, as capable in European languages as they are in their original English. And so the European Union's large language model initiatives are critical to achieving a more equitable and equal access and performance in these tools, because languages are not equal. So even if a tool maker says they support 20, 30, or even 200 languages, that does not mean that they're supported to the same impact. The example on the right comes from OpenAI's Whisper, a speech-to-text tool. And that speech-to-text tool provides or supports languages even to India or even the smallest European languages. But if you look at very carefully at this chart, it's kind of a tree chart where, say, Spanish or Dutch seem to be the best languages, but a language like Danish is far behind. We cannot talk about equitable access at this point of time, and equality and capability and quality. So Europe needs to be moving in this respect. Of course, we estimated the size of the market for language technologies. And while last year we estimated it somewhere between 19 and 33 billion euros, this year we can see that it's somewhere between 30 and, last year in 2024, between 30 and 41 billion euros. We also estimated to grow somewhere between 25 to 30%. That's a very strong growth outlook. And of course, large language models seem to be leading the space. But bear in mind, as we already mentioned, Josef as well, that language technologies are interconnected. Second on this list are chatbots, which are a very big market. But chatbots are actually fueled by large language models. So is machine translation. And generally, the new wave of language AI, generative AI, is also fueling speech-to-text, text-to-speech solutions as well. So this categorization makes sense Adding these numbers up makes sense, but comes with a caveat to say it is impossible to clearly separate where revenue at companies and actors actually belongs into which category. Next, to speak a little bit about what language technologies can do or can't do. Number one, they can help solve communication problems, but that's great news because there is so much content, there is so much need for communication that humans can't process all the volume. And so there is need and continuous need for improvement for language technologies to provide this support where humans can't. Also, language technologies can help with productivity, but there's never enough productivity gain. So there is a hunt for it. As well as language technologies can create the foundations for language equality and equity, but given the asymmetry that is driven by market forces, in other words, demand, large language technology providers, big AI companies, they will create solutions for those markets which have paying demand. But the truth is that basic language technologies are almost free and available widely, including machine translation. But if you look at ChatGPT or Gemini or Copilot, some of the new wave AI tools, they are also essentially freely available. And we predict that very similarly, other generic language technologies will follow suit. Next, a little insight into how well AI tools work nowadays. This is a screenshot from my YouTube. This was me using YouTube and watching an advertisement on YouTube. I live in the Czech Republic, so this all looks good. This is a Czech advertisement for me to download Chrome. YouTube and Chrome both being Google tools. But I use my Chrome browser in English exclusively, even though I do speak Czech. Plus, Google is trying to advertise to me that I should download Chrome in a browser that I'm already using, in a language that I typically don't use, from the App Store, which I never use. And so AI and all the calculations behind producing this specific ad for me seem to be misled. And that kind of says AI can make mistakes, but AI can make specific structural mistakes. At the same time, there are amazing initiatives. This comes from yesterday. Language is the last barrier, says this video, also on YouTube, also by Google. If you look at the top left corner, this is Dolphin Gemma, how Google AI is helping decode dolphin communication. An amazing and fantastic use case. So AI on the horizon is, to us, it's invisible what it might be capable of doing. The use cases that language AI tools are being deployed to are fantastic and amazing, being aware of the caveats that they're not always right. As we know, there is a language industry, a language technology industry, and a whole market for it. Tens of billions of dollars. But if many tools are free, why is there a market even? Number one, the quality argument, of course, is, well, the generic free tools are just not good enough. The niche argument is that generic solutions will provide, well, generic responses and generic outcomes, whereas individual enterprises, businesses, and organizations need to be catered to their specific needs, their specific domains, functions, and use cases. And language is typically not the core function of enterprises. They might have a language program. They might have a handful or even a dozen people working with translations. But more often than not, technology and the related services, such as translation or interpreting, they're outsourced. And this is exactly true for language technologies as well, in general. And so the key driver of language technology actors and their revenues is providing to the specific needs, providing solutions to enterprises. Because in a business-to-business setting, being 80% correct or even 95% correct does not solve the problem, and that there is almost always an element of human in the loop. Very importantly, about There are foundation models, of course. They're expensive to create and train. On top of that, you can solve different language tasks with specific applications. And so the most visible ones are the applications, and the foundation models, even though they might be hyped a lot nowadays, they're typically invisible in construction, in nature, and there's no roadmap for them. And there's the iPhone effect, which is I predict that the best language technology tools are the ones that I don't need to know how they work. An organization, when they develop their own tools, an enterprise that deploys AI on their own end, they IT people, they're developers, they need to know how these technologies work. But the users who use those tools, would that be for translation or for email writing or other productivity actions, they don't need to know how these tools work. They will use their mobile phones in a similar way as they will use language technologies in the future, which is, it's just another tool. It's a box that does the job that it needs to do. Of course, you need to check the output. Of course, you need to verify and validate. And importantly, humans governing the data that goes into those tools for development will still be needed. And let's face it, language technologies will keep improving and evolving. And as our study found, innovation is undirected. That's supported by this Stanford data, which says that in 2024, about 90% of notable AI models, including large language models and mainly large language models, came from what they call the industry. And a lot fewer come from industry, academia, collaboration. Importantly, because industry is creating these tools much more than academia previously, there's a new wave of investment into language technologies. And there's a new wave of startups being born every year or even every month. And innovation can come from anywhere, although mostly it comes from big tech. So let's talk a little bit about big tech. Number one, benchmarks saturate fast because big tech are developing frontier models against benchmarks, which means they can be very deceiving. It means it's easy to report out on results when these AI or language technology developers create their tools. But you might find that for your own specific use case, your real world use, they might be lacking. At the same time, what big tech and AI labs do with language technologies is they democratize language technologies. And next to them, there's a long tail of specialized language technology providers that customize the foundation models. And of course, there is a challenge with big technology companies that they obscure the data training and the usage. We don't really know how the most advanced frontier models are developed, what data is used, what bias they might contain. Next, big tech are clearly important in the market. And in Europe, unfortunately, there are a few. Mistral being one of them. Aleph Alpha and Silo may be mentioned as well. But in the US and in China, these big tech and AI labs, they are prominent and they are driving the vast majority of the AI models. Those three models that were developed in Europe last year, notable AI models, they came from Mistral. At the same time, of course, the big AI labs, they try to achieve what is called platformization or platform lock-in, which is to say, please come to our tool, please come to our platform and stay here. Do not go and do not try another tool because you will not need it. We provide and cater to every specific need. However, not customized needs, which is exactly what some of the smaller players have the opportunity to grow with. Next, as soon as I can move to next. Hello? Way too many nexts. I need to go a few slides back. Apologies, there seems to be a little technical difficulty with the slide changing. All right. What is necessary, though, to create language technologies? There are essentially three main components. Number one is computational power. The capacity to train and fine-tune and host and run all these language technologies and AI models and large language models as well. It's essentially a matter of financial power. And even though compute is expensive, it is generally available. When it comes to Europe, AI factories are contributing to this largely. The second main component is talent, and Europe is actually doing amazingly well in this respect. However, all the other major big tech companies and AI labs, they have European offices. They have European R&D centers. Essentially, European AI companies, European language technology companies compete in Europe with every other actor in the language technology space. Just recently, Anthropic announced that they're looking for, one of the American AI labs, they're looking for up to 100 European employees in their new offices for cost reasons and for talent competition reasons in the United States, which means European language technology and AI talent are much sought after. The third main component is data. And data quality, as we mentioned already, and the availability of data make a huge difference to the availability and quality of the language technologies. Last, I would like to speak about what's next about language technologies. And there are 6 main points that I would like to highlight. Number one, we see strong growth in demand. Yes, we also see that some of the questions being raised about revenues, especially when it comes to large language model AI labs. But undoubtedly, almost every enterprise that we talked to throughout this research, throughout this study, as well as in our regular work at Nimdzi, we found that almost all questions that come have an AI component to it. Everybody is interested in deploying large language models, generative AI in their workflows, not just in translation, but again, in customer support, in sales, in marketing, even in R&D and product design. Second important point is that the lines between language technologies and within categories within language technologies and other tech are blurring. And it's primarily because, well, AI labs, they are looking at creating what is called AGI, artificial general intelligence, which seems to cover almost any use case, almost any function, almost any activity. So it will be soon enough almost impossible to say what technology is language technology and what isn't, because language technology will be built into other platforms. Third, agentic reasoning and multimodal systems are on the horizon. Reasoning systems with OpenAI's O1 or DeepSeek's R1 or from Google, etc., they're already on the market. Agentic systems are coming, but in many ways, agentic systems create a large black box from smaller black boxes, unless they are created transparently and in a supervised manner. Number 4, custom and small models are more efficient than the largest ones, not just in computing expense, but also on data. They have an importance on the market, and many argue that these small targeted models will create better value for enterprises and users than using just the largest models altogether. We'll see how that plays out. Clearly, there will be a continued coexistence of proprietary and open language technologies. Proprietary ones that you can use either in a web interface or through an application programming interface API, and open language technologies that essentially you can download, customize, and deploy even on premises and on site. These will coexist and will create what we call a paradox of choice. It is incredibly hard to determine, or a large amount of effort needs to go into determining which tool is actually better or most beneficial for a specific use case and deployment. Last but not least, language technologies are here to stay. They are replacing some jobs and some expertise, but human experience and expertise, especially when communicating with other individuals, is irreplaceable altogether. So AI language technologies are here, and they're not replacing all humans, at least not yet. With that, I would like to see if there are any questions that need perhaps answering. And we will take a short break before we move on to the mini sessions about the specific language technology categories. All right, just looking through the questions quickly. Okay, this was answered by Philip. How do language technologies protect language diversity when the LLM is producing incorrect utterances which can be used to train other models? That is an excellent question, because it looks like large language models create a lot of synthetic data, and the synthetic data may be used for inserting it back into AI model training later down the road. There are plenty of worries here, admittedly. And Philip responded partially this answer to say, detecting AI output is a continuous challenge, especially because, well, many of the AI output has been already edited. And so if it's edited, does it still count as AI output or human output? What can go into AI training? What cannot? What is the cutoff of the data that can be used for training large language models? A very challenging question for AI developers and researchers as well. All right, looking for any other questions immediately to be answered. And I see that a few of them have been answered already in writing. All right, so then we take a 10-minute break and we will reconvene at 10:20 to continue with the breakout sessions. Thank you very much for your attention. It's 10:20. Hope everybody had a chance to grab a cup of coffee, and we can continue with the agenda. And so now we're going to dig into large language models, text-based language technologies, and speech-based language technologies. As a reminder, let me find, here we go, housekeeping. If you're just joining, don't forget to raise your hands and ask a question in Slido. If there are polls, we're looking forward to your response. We are recording this, of course, and will be published on the European Commission's Digital EU YouTube channel, and you can visit the project website at the attached QR code. Moving on, we have a lot to cover because we have roughly an hour and a half. And last year we had a whole day conference and an entire afternoon for these three main categories of language technologies. Today we have about 20 minutes for each of them, and after each session we're gonna look at the questions and try to answer them as well, unless if my fellow participants and hosts, they will answer them directly in writing. So about large language models, I will do this on my own, and then I will call on my colleague Jourik Ciesielski to join me on the stage. I would like to do an introduction. I don't think it's necessary though. Probably everybody knows ChatGPT or Claude or Gemini or similar tools out there. Importantly, the new hype is the natural language interface. The language models have been around for many years, 8 years specifically since the Transformer was born. And critically, they are democratizing multilingual and productivity applications and their development. And the market for large language models, as Josef already mentioned, is in the billions of euros. There are some core issues, though, with large language models, and you must have faced them previously. And if you work at organizations, if you work in an IT team or a language technology developer, you know that they are very expensive to train and to run. However, they're getting cheaper. You might also know that they might produce biased outputs. Let me quickly know the biases are subjective, which means in Europe, we have our set of values. In the US, there are different ones. In China, there are completely different ones. Each will perceive the other one's biased. Would that be on political, cultural, gender-based, or whatever issues? A third issue is privacy and security, often raised. Confidentiality and misuse concerns. And this might be a risk for many enterprises. However, you can build large language model-based applications on-premise even. So that possibility is always open. While these typical issues can be to a certain degree solved or understood, there are real challenges that are unsolved at this point of time. And some of them are here, such as languages are not equal. Not all languages are supported equally. So somebody using a large language model, say ChatGPT, in Estonian or Hungarian, such as myself, would experience probably very different level of quality than, say, in English, the most widely used language and the most widely representative language in the data set. For enterprise applications, there are many pilots and experiments being run, but they're not trivial to put into real-life operations and realize value. And there are other challenges, just for a quick mention. Of course, there are environmental challenges. Of course, there are copyright questions, a lot to be asked about that. And there are governance models such as the EU AI Act that provide, depending on your perspective, barriers or guidance as to how large language models in different use cases can be deployed. But if there are so many core issues, seeming or real ones, why it up now? Well, because number one, productivity is a competitive advantage. Number two, these tools are developing. And so a learning curve that you can start now will benefit you sooner than if you started later. And number three, because good enough is just what it is, it's good enough. Which means if you can get productivity out of these tools now, don't hold back on them. Now, when talking about LLMs, we could be speaking about prompt engineering, or how large language models can be used even in content creation or localization or code generation. And there are different webinars that we at Nimdzi, we could host you. This is not the space. We're doing a market study. But here are some latest developments that are relevant to large language models, at least some of them. On an application layer, what we see is, of course, reasoning models are something that are coming around. OpenAI's O series, or DeepSeek R1, the big Chinese DeepSeek moment, as they call it, or Anthropic's Claude, extended thinking, Gemini 2.0 flash thinking. These are all models that what is called through inference time computing. They run the model multiple times to find the best possible answer out of all the answers that the models provide in some shape and form. They imitate or they produce output that looks like reasoning and may be considered even reasoning, and very often it may be even correct. Importantly, there are models that are specifically created for language purposes. And these would be, examples of this would be Translated's, an Italian company's Lara, or Unbabble's Widen tools. For content creation, DeepLWrite or LilCreate or writers, Palmyra models are really useful and important. Large language models are often used as coding agents or coding co-pilots as productivity tools. And you can ask the question, if they're really so great, why are not software companies laying off hundreds, thousands, or hundreds of thousands of software developers? Well, that's because with productivity, you can do more. And that's exactly what is happening. There's more code being developed, and AI, large language models are being used for that. Last, very importantly, computer use, which kind of creates the space for what are called AI agents. And OpenAI and Anthropic, and there are different other models as well, even open source components, which can create what is called computer use. You can instruct your large language model-based AI tool to actually move your cursor, click on things, do investigations, even purchase things for you if you are willing to take the risks with it. On the foundation level, there are also developments, or at least parallel tracks. For example, other than the traditional transformer models, that are also what are called Mamba models, a different architecture. And these are visible in products like Jamba or by Mistral, CodeStral, a Mamba-based model. As I already mentioned, inference time computing and self-reinforcement learning for reasoning models is on the foundational level. The curious thing there is these models can be so expensive to run that AI labs are selling this for $200 and even considering to monetize this at $20,000 a month per seat. And if you think about it, $20,000 a month, that's quite a few employees worth of money. If they have this kind of benefit, or they will have it in the future, remains to be seen. And it will also be a kind of blurred what model is being used, because a next point is multimodality, or rather hidden modules under large language models or chatbots is the future. And OpenAI already announced it, that GPT-5 will probably be a collection of models under the hood. Again, a big black box as a collection of smaller black boxes. Costs are going down, which we see as more than 100 times cheaper per token over a year, which leads to commoditization of large language models. And very importantly, there's a shrinking gap between proprietary frontier AI models and open source or open model, open weight. There are, again, blurred lines between there, but those models are becoming as performant as the proprietary models and at the faster space. Yes, on the right, there are a few funny looking items. With all the capabilities that large language models and AI, and with the promise of Gen AI, artificial general intelligence coming from AI labs, some of these may seem funny. The trick is that these are really hard to correct. The capability to count the number of R's in the word strawberry is not simply going to the code and correcting a counting mechanism. Rewiring an entire big system to be able to answer every single question correctly is not trivial at all, and it's an unsolved challenge. Which is why investment is happening into these companies, because they need to be developed, plus they provide results, especially in productivity. And let's face it, the big AI labs, they're typically much less about solving interlanguage issues, multilingual communication. Big AI labs are much more focused around productivity, whether it be in coding or in customer support. These time saver tools are exactly what promote investment. And because, well, United States being more or less a homogeneous, linguistically homogeneous country, English is good enough to trigger a vast amount of investment into large language models, which can of course also be used elsewhere in the world, even with limited language quality across all languages. Europe has a lot to catch up on in this respect. And again, some of the investments that the European Union is making into this, together with support from the individual member countries, as well as, of course, industries that are getting into investments in developing large language models, they have a big role to play in this. When we talk about investment, though, let's quickly notice that the gap between Europe and the US is, at this point of time, widening. And just a month ago, OpenAI announced a roughly $40 billion funding, which dwarfs the entire private generative AI investment from 2024. And with that, of course, you would expect that quality is increasing. But language quality isn't necessarily. This is from almost 2 years ago by now. And this is Anthropic's Claude. And I love using this example because I'm Hungarian. If anybody in the audience speaks Hungarian, but for you, if you don't, I will translate it. The conversation goes like this. Me asking Claude, do you speak Hungarian? And Claude responds back, no, sorry, I don't speak Hungarian, only English. And that response is in Hungarian. There are latent capabilities in these models that are sometimes hard to find or quantify or understand. At the same time, often these capabilities are not even displayed by the models or misrepresented. That said, of course, the Hungarian version of Claude at that time was much weaker than it is now. And the reason for that is most of the targets that AI labs and big tech companies are trying to achieve are benchmarks. And benchmarks saturate fast. Benchmarks are biased, they're cherry-picked. Often the developers of language technology tools, and not just large language models, but also speech recognition or machine translation technologies, they pick benchmarks where their models are successful, and they're willing to ignore those benchmarks where they are less successful compared to competitors. And of course, unfortunately, most of the benchmarks that AI labs tout, they're English focused. There are language-specific leaderboards, but primarily for open language models. And there is almost, with the development, the proliferation of these language technologies and models, it's almost impossible to test every single model for every single use case and language, leading to a paradox of choice. But the imbalance in the capabilities is very apparent. English and software code is overrepresented in the training data of most models, even though the large language model providers, they do not disclose what data and how they use in model training. Llama 3 launched last year. By now there's Llama 4 model family as well. But Llama 3 paper specifically said 5% of the pre-training data set consisted of non-English data of 30 languages. And of course, it's really nice that they put there the disclaimer. They do not expect, Meta themselves creating the model, they do not expect the same level of performance of these languages as in English. The good news is that some of the models, open source or open weight models, they can be retrained. Data is needed for that. At the same time, large language models are here to stay, regardless of performance imbalances. And this, I think I used this comic also last year at the conference, at the Language Technology Landscape Conference, but it's still valid, which is there's a lack of clarity often in executive side at enterprises as to what generative AI tools, large language models are capable of doing and what they should do. In fact, that's one of the most frequently asked questions when we speak with enterprises is, okay, so how do we do things with large language models? Second most frequently asked question is, what do others do with it and how do they do it? There's a lot of learning, and as somebody said in a social media a few weeks ago, if the development of large language models stopped right where it is now, it would still probably take us years to figure out how to deploy them efficiently and effectively. But the development keeps happening, which leads to our market size estimations. We see the market for large language models growing and growing heavily. Last year, we estimated the total revenue of large language model developers to be somewhere between 1 to 2 billion euros for 2023. This year, we're estimating the 2024 market size to be somewhere between 6.5 to 9 billion euros, with a very, very high growth potential to somewhere between 15 to 20 billion in 2025. And this is a fundamental language technology category, again, interconnected with a whole range of other categories, including chatbots and conversational AI, machine translation, speech-to-speech translation, machine interpreting, and all the rest of them. And the truth is that the demand growing for large language models primarily comes from the fact that they are not purpose-built. They are universal, or rather, they are models that can seemingly perform a whole lot of tasks. They're general purpose tools. And the market character is simple. There are a lot of challenges and there are a lot of promises. And the balance in between them goes towards productivity, which is as long as there's a promise of improvement in the model performance in terms of productivity, time saving, there is reason to invest in them, and revenue for these technology companies will be coming in. The truth is, who are those main actors is a hard question to answer sometimes, because there are a great many AI companies or AI-ish companies out there that actually say that they build our AI tools from the ground up, but in fact they rely on proprietary tools, would that be GPT-4 or Gemini from Google or Anthropic's Claude or other models. The real main actors we list here with their 2024 revenues and other details. We see an overwhelming majority of American and Chinese companies. There are a few European ones as well. Unfortunately, compared to last year, we had to scratch one of them off, Aleph Alpha. In Germany, they allegedly no longer focus on developing foundation models. Rather, they focus on operationalizing the foundation models. Mistral and Silo having been acquired by AMD, they are the current flagships of large language model development in Europe. And of course, the new initiatives of EuroLM, Open EuroLM, and similar ones from the European Union are to balance the field with competitors from other regions in the world. But it is a big tech and major AI lab dominated category of language technologies, even though open model initiatives are strong. So Meta, Mistral, and DeepSeek, they do have open models that can be downloaded, customized, fine-tuned, and deployed on-premise as well. But the money-making problem is still severe, and investment lasts. We do expect that in the next 1 or 2 years, again, some of these players may stop developing large language models, primarily because a lot of the foundations are already there. Incremental improvements are certainly possible. giant leaps in performance are unlikely at this point of time with the existing architectures. For the technology outlook, here are a few things that we see for the future. Number one, small language models are certainly have a big viability. They're more efficient. They can run on smaller devices. They can be run even on premise. Developers can build purpose-built applications with them. And we see this already, that small models are important. Google has the Gemini models everybody knows about. Gemma are the smaller versions. They can, again, be even run on mobile phones, for example. Microsoft uses primarily OpenAI's models, but they also develop the Phi series, which are much smaller and purpose-built. But even OpenAI, right now, they just released yesterday, GPT 4.1. Interestingly, between 4.0 and 4.5, they inserted the 4.1, and that comes in various shapes and sizes again, from very small ones to the very large ones. Next, a mixture of experts, or rather black box monoliths. And the black box is, again, a combination of smaller black boxes, which says for an incoming request for the large language model, not the entire huge model is used, but specific sections of that model, which creates runtime efficiencies, energy savings, and cost savings ultimately, as well as speed increments. Grounding and explainability are a challenge that need to be tackled. And through RAG, retrieval augmented generation, or fine-tuning, more quality data and all of that can help reduce that to a certain degree. Multimodality, we already mentioned. Small models will help custom and task training and fine-tuning of models. And very importantly, there are open models that can bridge many of the gaps, especially when it comes to low resource languages. And again, in the EU, models like EuroLLM, OpenEuroLLM, as well as there are many country-specific models, they can potentially do this. And of course, similar is true for other regions in the world, would that be India, Africa, or Southeast Asia. There are models for Indonesian languages. There are models for smaller groups of African languages. There are models specifically created for groups of Indic languages. And we know that even in Europe, there are many country-specific models, say the Plum models in Poland or Puli for Hungary. And there are many models for Dutch or for Spanish that are being created. And there are many language technology actors in Europe who potentially even get grants to some of the European supercomputers, and they can fine-tune and retrain open source models to serve their own enterprise customers. We know examples of these from Pangenic to Lingua Custodia in France. All right, I think my time is more or less up for large language models, and I would love to know if there are any questions that need to be answered before I call on my colleague, Jourik Ciesielski, to join me on the stage. Given, a few questions. One question, given that what we saw coming from China, are tools pricing fair? This can affect fair investment estimations. That is an amazingly good question, Agata. The challenge is that we know that from China, one of the purposes of these Chinese models is also to disrupt the US kind of dominance in large language development, large language model development, which means many of those models are cheap to run, but US companies will almost never opt, or European companies probably will also never opt to use Chinese models that are actually hosted in China. So cost-wise, it may look like it makes sense to use Chinese models over US models, but the trade-off is not trivial and not immediate. Fairness is a good question. It's hard to say. Again, just like with machine translation, where some of the tools, Google Translate or Microsoft Bing, they're available free of charge. Is it fair that other technology providers would charge per seat or per month, or a similar way for machine translation, which has become a commodity over the number of years? It's more a question of business opportunity. And what we see and what we expect is large language models will probably on many use cases will reach similar commoditization as machine translation over the years. This is one of the reasons why the AI labs, they try to push the frontiers or create new frontiers that they can push, at least in marketing communications. Would that be about AGI or similar concepts, but also in use cases where the typical enterprises would not participate in. Would it be in research and development and similar areas where investment is actually, lack of investment is prohibitive in development of the technology. So pulling in another 10 or 40 billion dollars into developing large language models by Anthropic or by OpenAI or Microsoft or Google, they probably lead to results that will be outside of our everyday lives. Hope that answers the question. All right. So if there are no other questions right now, is it easy to estimate how effective these investments are? That's a really good question, again, Agatha. And the answer is no, it isn't. And there are many voices that say that given the lack of revenues at the largest AI labs, indicates a complete failure of the large language model, transformer-based large language model ecosystem and market. That might be true. And this is again why many of those AI labs try to push at least the verbal boundaries of what these models are capable of doing. And it will take quite a few years to find out whether the investments were worth it. There are currently a lot of bets that are being made, and those bets are easier to make in the US than in Europe. Europe is traditionally, again, more risk averse. So venture capital is less relevant in developing language technologies, such as large language models in Europe in that sense. Venture capital in the US is much more risk-taking. And so many of the investments that happen there, they're known that many of them, 9 out of 10 will fail. And of course, betting on the biggest horses is often a seen strategy. But it seems that the core AI model developers in the US, they continue to be strongly supported by venture capital and similar funds. All right. And again, questions and answers, of course, anytime later when we have questions, happy to answer them. Jeffrey says, the cost of tech development is indeed expensive. The cost of data and metadata creation production is also very expensive, especially for curation, dialect variation, etc. Jeffrey, very true. I personally, I use large language models all the time. And it looks, even in our world, in market research and consultancy, large language models could do a lot of the work or support a lot of the work that we do to make our work more efficient. But when it comes to using large language models specifically on our data or on our research and our findings is not trivial. And so customizing models that help us instead of creating generic output, which nobody really is interested in, is an unsolved challenge for many of the enterprises. This is again going back to in the executive summary earlier this morning, a BCG study found that 74% of the companies, if I remember the number correctly, found they haven't really seen return on the investment just yet, even though they have tried applying AI. Martin asks, shouldn't LM models be understood as both natural monopoly and public good, which could be used by society for its improvement rather than just an investment opportunity? I think that's an important question, perhaps not necessarily for a market study. Definitely a question that the European Commission and the European Union generally is trying to answer. Public good is something that the European Union holds up really high in value. And so certainly it is something that needs to be supported across Europe. And I think Philippe at the beginning of the conference talked to this to a certain degree. All right. Given that this is half an hour about large language models, what else would we talk the most about at the Language Technology Conference and not language models? we're not going to ask forgiveness about that. But there are other technologies that we would love to talk about. So I would like to call on Jourik Ciesielski, our technology consultant and researcher, to join me on the stage, because we're about to talk about text-based language technologies. And for that, text-based language technologies include machine translation, translation management systems, and other tools such as quality assessment, optical character recognition, and also alternative inputs as well. And we have roughly 15, maybe 20 minutes for this. And we're moving on from here. Let's start with machine translation. I will start and then hand it over to Jourik. We estimate that the market size is somewhere between 2 to 3 billion euros. And there is low interest in investment in machine translation specifically. You might say, but Laszlo, DeepL has been getting a lot of investment lately. And that's on the next slide, which is to say, DeepL has $400 to $500 million investment till date. That is true. But DeepL's investments are for two reasons. One of them, to disrupt the big tech dominated machine translation space, yes, but it's also developed their own large language models that can not only do translation, but can also, as they have introduced already, DeepL write and other tools in the language space. So again, going back to the productivity paradigm, the investment to DeepL is most likely not simply into machine translation as a use case, but for language technologies as a productivity tool further down the road. That said, this is a fairly mature market. It's been around for a long time, and large language model adoption is ongoing. What we see is the demand will only keep increasing for machine translation. But the truth is that machine translation, at least the traditional one, is essentially free of charge, even if you're paying for it. Per token or per word or per character, it's essentially insignificant in terms of cost. But the raw machine translation output is not directly used only in certain scenarios. Importantly, again, big technology companies dominate the space, especially from the US, but also from other regions of the world as well. And there are very specific machine translation companies that are also active in the space. And again, from Europe, players like DeepL or Globally, recently acquired by MemoQ, or Systran by Champsvision, or Pangeanic, Unbabel Translated. These are all really important actors in the machine translation market. And I'm going to hand it over to Jourik, I think. May I? Jourik, are you with us?
Yes, I am here. Can you see
Perfect.
me? Can you hear me? Yeah, cool. First of all, thank you, Laszlo and the European Commission for having me on the program today. Thank you, Laszlo, for the introduction. It's yeah, I think it was spot on. I think the deal with machine translation is that it's everywhere. It's very easily accessible. If you want to read a piece of content in your mother tongue, you can do it, and it will not cost you a lot of money. It will not take a lot of time to convert text into your mother tongue either. And of course, the big reason behind this is the fact that machine translation has been completely commoditized by big tech. And the interesting thing about this is that big tech doesn't have, you know, Amazon, Google, Microsoft. They don't have this really intention of selling machine translation to their clients, to their users. What they want to sell to their clients are data science solutions, and machine translation is just one part in this bigger data science package, and it's typically accompanied by other services like speech to text and text to speech, and we will be talking about those services as well in this presentation, and we will be well saying the same thing there as well. This also explains the growth potential and the investment interest growth potential. There is a lot of growth potential in the automated translation discipline because we are witnessing a huge rise in the amount of available content, the amount of content, translatable content that is out there. So there will always be a need for better and more context-aware translation solutions. But when we look at machine translation as a technology, neural machine translation technology, the growth is, of course, relatively low. Big tech commoditized it, which means that there's not a lot of interest in terms of investment. We are seeing some acquisitions globally. This was recently acquired by MemoQ, but that's not enough to say that that there is a huge interest in investment and M&A. So Laszlo, you took me to the technology outlook slide, which is good. I think it's fair to say that neural machine translation has reached a quality limit. It's not going to get any better than it is today. There are a couple of unresolved challenges in the field of machine translation. Think about low resource languages. A language model is only as good as the training data it has digested, and that is still a very hard nut to crack for low resource languages and exotic language combinations. Another typical problem are out of context translations or out of domain translations. We thought that we would be able to leverage our translation memories to train machine translation models across domains to be super specific, super targeted, super tailored across many language pairs. But I think it's fair to say that, well, this didn't exactly happen, and out of context translations, out of domain translations continue to be a serious problem. And of course, now we have something new. I think it's fair to say that sooner rather than later, large language models, which have been comprehensively introduced by Laszlo, will become the default for machine translation, probably completely washing away traditional neural machine translation solutions. And there's a lot of proof to say that this is happening already. This is really happening. We are seeing companies that are fine-tuning LLMs, so foundational models from Mistral, from Llama models, for example. They're fine-tuning them on their own data and commercializing them, productizing them as translation LLMs. A couple of examples: Lara by Translated, Widen by Umbabel, Echo by Pangeanic. And the interesting thing is that this is bringing like a whole new competitive edge to the automated translation space, because fine-tuning is one customization technique, but it's not the only customization technique. There are many other things that you can do to produce contextualized translations with large language models. Prompt engineering is one example. Retrieval augmented generation is another example. RAG, knowledge graphs, agents, etc., and so on. On top of that, large language models can do other tasks besides translation. It's not just translation. You can use the exact same model for source rewriting or source optimization, for quality estimation methods, for automated post-editing, and for automated QA, LQA quality assurance. So I think the conclusion here is that there is a brand new competitive edge in the automated translation space. No surprise that this new competitive edge is completely inspired and driven by large language models. Okay, can you go to the next slide, please, Laszlo?
Jourik, I just quickly wanted to add, if I may.
Yes, of course.
We heard from one of the largest machine translation technology companies that they recently, when they established a localization department recently, which sounds very strange, right? You have a machine translation company that establishes a localization department inside. Well, why do you do that? You already have the technology. Why don't you just translate your own stuff with your own machine translation engines? And the answer is, of course, because it's not that simple. Machine translation engines, what they provide is automated translations that look like translations, but they're not the final product that need to be produced. However, these engines and all the augmented tasks, they provide immense what is called leverage in the industry typically, and productivity gains. So machine translation, of course, can help reduce translation time, whatever, 20, 40, 50%. And then these additional pieces, quality estimation or automated post-editing, they can further reduce depending on the content. So tech support content or customer support content can be almost fully automated with these technologies, almost completely. For the high value and business critical translations, of course, the human review, extensive human review is really necessary. But that kind of showcases that machine translation for many types of content, especially user-generated content, is almost trivial to use in its raw form. But anything that has a higher risk level associated with it, any content, you will need the human input into it. Moving on to a next slide, then, Jourik. Oh, yes.
Thank you very much. Yeah, good one. Yes, we were talking about customization techniques and the many things that different companies are doing to gain competitive advantage over their competitors. And one of those customization techniques are AI agents, translation agents. And this is very interesting. And I would like to spend a couple of minutes talking about this. So the thing is that with machine translation and other technologies as well, by the way, we are very used to sending something to the model and getting something back. And if it doesn't work out as expected, there's not a lot we can do. We just have to live with it. This is a little bit different when we use large language models for translation purposes, because of course they can process a lot more data and a lot more references and a lot more context to produce a translation. On top of that, those models, they work a little bit like humans, and that's a little bit of a controversial statement. But what I'm trying to say is, if you give a large language model 5 very targeted instructions, it will probably apply them to perfection. If you give a large language model 100 or dozens or a high amount of unclear and vague instructions, it will make mistakes, and humans will do the same thing. If you fail to give your human linguist the appropriate context, he or she will probably also make mistakes. Now, the thing with LLMs is that instead of doing everything into one big API call or one big prompt, we can perfectly chunk the translation process down in multiple iterations, and every iteration, in the process is supposed to have one specific goal, one specific purpose. And that's what we call an agent. Different AI iterations where the output of one iteration is the input for the next one, which is something you can do to achieve complex end-to-end goals, in this case, translation. One example of a translation agent, you could start with the first iteration, which is a simple translation agent. Content gets translated from language A into language B with an NMT engine or with an LLM. Then we have a second LLM iteration to fix and validate terminology, correct any errors that might be there. Another LLM iteration to ensure style guide compliance, brand requirements, legal requirements, etc., and so on. And when you do multiple LLM iterations, of course, the chance of hallucinations also increases. So you might add another LLM iteration to just do some formal QA, length restrictions to be checked, inline tags maybe that need to be checked and corrected. And so on and so forth. This is just an example. You can add as many iterations as you like. And if that's not enough, you can add another one where you prompt your LLM to do a quality estimation. Dear model, this is the current translation. What do you think about it in accordance with my style guides and my terminology? If it's a pass, cool, we go live, or we send it to an automated post editing. If it's not good enough, a fail, we do another post editing, perhaps with a human. And again, this is just an example. You can really build the agent that you need in accordance with your own needs and wishes and quality requirements. And the last thing that I want to say about this is that every iteration, every LLM iteration is of course driven or can be driven by your data, your content repository of terminology, glossaries, translation memories, style guides, legacy content, you name it. And I think this looks very good, and I think this has a lot of potential to really break through in our industry, the language services industry, for automated translation purposes. Laszlo.
And I want to quickly add that because all these pieces of technology that are kind of depicted here, they are democratized, they are available to anybody. Enterprises or organizations such as the European Union or European Commission can build these agents themselves. But there is always kind of, and that's the key message here, that they look lovely and automated, but there has to be room for human intervention and validation, even in the individual steps, even not necessarily for every piece of content and every single word, but overall for monitoring and managing the system, which leads us to our next category, which is translation management systems, which is essentially exactly where the coordination of these tools with the human expertise, the linguistic expertise is put together into a single place. And it includes, of course, translation management systems include a whole lot more than just an editing interface and all of that. And the market is not that big, but they're critically important because translation management systems in the language world, they are the backbone for creating multilingual content, at least at this point of time, as much as they are being challenged with multilingual content creation as such via large language models. And the market is probably less than €500 million in size, and there's probably maybe a moderate growth potential for them, depending on how far they can incorporate and implement large language models to more efficient content production, multilingual content productions. And of course, enterprises and language service providers, they do use translation management systems. They may consider creating their own, but as we know, with so many other infrastructural technologies, it takes years to develop them. And there are very mature solutions already out there. Here are listed the most prominent translation management system solutions. And most of them have been in the space for more than 5 or 10 years. And European actors, just like in machine translation space, they are prominent on the market. And major differentiators include questions such as how far does a translation management system connect even automatically with the content management systems, the publication interfaces, as well as what kind of intervention spaces it provides for language talent or for content creators. AI, generative AI, large language models are the new disruptors, of course. So translation management systems, of course, incorporate machine translation, and lately, of course, large language models and other modalities are hopefully coming along the way for translation management systems. Jourik, do you want to add a few thoughts on what large language models and translation management systems doing together? Again, talking about the interconnectedness of language technologies.
Yes, absolutely. So first of all, I think a very important comment that we have to make here is that TMSs have been around since like forever, since the 1980s when Trados was introduced. And the truth of the matter is that those systems have never really changed. They only got more comprehensive, bigger, more features for project management and reporting and communication and APIs and integrations and this and that. But the core of it has never really changed. TMSs are the beating heart of basically every language service provider, but also in every enterprise localization program. I think it's fair to say that TMS is having a pretty hard time now because of the introduction of LLMs, and I will tell you why. People have always used TMSs, and people have always blindly trusted in TMSs. And that's a good thing. And it also gave the TMS market the freedom to like promote itself as AI first and AI driven and AI enabled. But that was prior to the introduction of ChatGPT in 2022. And people never really questioned what the AI programs of the TMS providers could entail. Of course, November 2022, ChatGPT, the whole wild world had a taste of ChatGPT, acknowledged, the very nice things that you could do with such a solution. And we also realized that there was nothing similar in TMSs, and the TMS market was really caught by surprise. I can tell you that. So what happened? The TMS market, they started releasing all kinds of LLM-driven features at the speed of light, But the truth of the matter is that the real quality and the real business impact of those features hasn't really kept pace with the speed at which they were released. On the other hand, the positive thing is that it brings a brand new competitive edge to the TMS market because it gives the market new differentiators, new areas where TMSs can really stand out and gain competitive advantage. Orchestration is one of them, connectivity, as mentioned by Laszlo, multimodality is another one, processing more than just text. But of course, the main one is LLMs. I don't need to tell you that. This is being done. And the nice thing about it is that different TMS providers are taking different directions in their LLM implementations. And we try to like categorize it on this slide. And we have determined 4 categories: aiming for high impact, freely integrating, focus on proprietary products, and task-specific implementations. Very quickly, what do we mean by that? Aiming for high impact, you will see the logos of RWS, GlobalLink, TransPerfect, and SmartLink in there. What they try to promote to their clients are AI-driven translation services with humans in the loop. So they provide or they sell a process, including source optimization with LLMs, machine translation, automated post-editing, MT routing, MTQE, human sign-off, etc., and so on. Which is why we want to label it as aiming for high impact. It includes everything, not necessarily saying that they are realizing more impact than the other approaches, but that's what they want to do, aim for high impact. Freely integrating, a couple of TMS providers, they don't have any kind of dependency, no acquisitions, no legacy system, so they just freely integrate and do whatever they feel like doing, which leads often to good results. Phrase is an example of a TMS that focuses on proprietary products, own development, and MemoQ has taken a clear direction towards LLMs for machine jourik purposes. They have their own GPT-driven solution, and they acquired globally. Laszlo, back to you.
Thank you, Jourik. Really appreciate it. And I think the overarching message is what large language models do as the biggest disruption is they challenge what is called the segment by segment paradigm in translation. Everything around the translation memories and the traditional machine translation systems were built around that segment-based model. And large language models are more than capable of taking context into consideration, either in the prompt or from a other database or even through fine-tuning. And contextual translation suddenly become possible, and you can even take, through the multimodality of large language models, you can even take screenshots or a web page layout or a wireframe to give guidance to the model to provide better translations, for example, for length or for other consistency across terminology and all of that. Amazing piece of technology. We are looking forward to seeing how the translation management system market adopts to this disruption. That said, we have probably a few minutes to very quickly go through additional text-based language technologies before we jump into the speech part. And QA tools are actually a smaller market or sub-market of language technologies where there are some very important players. Importantly, of course, it's a mature market on its own based on the typical rule-based systems, which are very often plagued with false positives and require a lot of human oversight. And the new paradigm that is coming along is automated language quality assessment and quality estimation, which essentially mean that the machines can help decide what is it that needs to be looked at by a human and corrected and validated, and what is it that can be considered as good enough, as mentioned previously. Next, importantly, the Achilles heel of almost every translation system is the non-editable files, whether it be images or PDFs or other documents, which are really important not only for the translation industry, but generally for the digital and digitization initiatives at companies over the past years. And optical character recognition, OCR, is embedded into many systems, and even though it's available also as standalone applications, but systems from Adobe or OpenText, Konica Minolta, ABBY, or Foxit, they all provide OCR capabilities within their platforms. The new thing, of course, is that it connects with large language models. What do you know? Especially visual language models that can use an image as input and provide text as an output. And very specific examples of this, one of them comes from the Czech Republic, Rossum, but also Mistral, the French AI lab, recently announced Mistral OCR, that kind of gives a glimpse into what the new capabilities might be, which is not just simply convert one data set into another data set, but also to provide a conversational experience, potentially, and refining iteratively the output by being able to direct the model even with specific examples. Next, importantly, for accessibility, Braille technologies, and for the blind or vision impaired individuals, this is a really important technology. But mainly, of course, this is a physical device very often. And the critical thing here is there are very few solutions out there that actually support a wide range of languages, say all EU24. We would certainly advise that in the inclusivity and accessibility space, Braille technologies are fostered further, also with the use of machine learning algorithms. Sign language is a really interesting segment for language technologies, primarily because sign languages are just as diverse as natural spoken or written language. And there are about 430 million people who are affected by disability or hearing loss. And sign language is typically, or sign language interpreting is typically a human activity, but nowadays, of course, AI avatars and machine vision technologies help convert the movement of, especially the hands, into speech or captions. In reality, the challenges come with the fact that sign language is really multimodal in the strictest sense, which is even facial expressions and movements contribute to the message. The sign language in the world, only few of them are supported, and the typical ones are, of course, English, American, and British Sign Language, and a few of the major European sign languages. The good news is that there are technology initiatives to help solve the problem. As we see, even interpreting service providers are looking at these technologies. For example, Sorensen, the largest sign interpreting provider, they acquired HandTalk and Umbridge in 2024, indicating that there's room for kind of machine sign language interpreting in this space as well. Last but not least, language education. And you could say, hey, Laszlo, why are we talking about language education? What does it have to do with language technologies? Well, the challenge is that while language technologies do help to solve many of the multilingual communication issues, they are not necessarily representative of the cultural values and everyday human interactions. It's human-machine interaction by and large. And so the ability to speak another language, not just when traveling, but also in business communication, can be really important. And so the market, which is roughly estimated at $2 to $3 billion now, with key players such as Duolingo, Babbel from Germany, Busuu, or Speak AI, Rosetta Stone, Memrise from the UK, they're really important to help foster the notion that actually learning and speaking in another person's language brings cultures and peoples together. And AI also helps here. So large language models, you might have seen also recently, quite a few commercials are coming out with this. AI avatars based primarily on whatever OpenAI's tech stack or similar are providing an experience as if you were talking with a language tutor and in a conversational engagement, immersive interface. They provide language tutoring. And the market is specifically growing. We know that Duolingo is developing fast. Babbel is doing really well in the market. And the range of individuals who get access to language education through this is an important contribution to inclusivity and diversity and maintaining linguistic diversity as well across Europe and other regions of the world as well. Moving on, I think it's time that we went to speech-based language technologies. And Jourik, I think I will call on you again at some point of time. And I will start out by saying, well, this is a kind of a meta category where speech can be the input or the output, sometimes both. But specifically, we talk about technologies such as speech-to-text or automated speech recognition, ASR, text-to-speech, and well as derived technologies such as machine interpreting, speech-to-speech translation, AI dubbing, and chatbots, and conversational AI. So with that said, the basic is, how do we convert speech into text? Why do we even want to do that? You could say, well, there are various use cases, including captions or subtitles. So I believe that even now, the tool that we're using, WebEx, can provide captions in English. Subtitles on YouTube, multilingual subtitles are by now, they're commonplace. And there's a pretty big market for speech recognition or speech-to-text technologies, somewhere between 3 to 5 billion. Of course, the challenge is that that's just basically pure technology. So the actual speech-to-text and speech recognition market can be 4 to 5 times or 5 to 6 times bigger even, depending on how much professional services we count into that, including data collection, data pipeline training, and custom deployments. But it's a fundamental technology, not just because it provides simple things like transcriptions from a meeting or subtitles and captions in videos, but also because the text can be further processed by additional technologies, large language models or machine translation. So it's a foundation also for composite language technologies. That said, yes. This is also a space where typically American actors are pretty much covering the space. They dominate here, including the Googles, Microsofts, and Amazons, and all of those. And there are a few very specific companies that develop primarily on open source toolkits. They provide custom services for their clients. The important note to make here is that speech recognition is also built into a great many platforms on its own, and it's not necessarily visible as a separate or an integral piece of the speech-to-text market, because they're basically, in one sense, they're being commoditized. But the base models are typically fairly good quality, we must admit, supporting a wide range of languages or smaller ones. One of the research questions for this study was, which language technologies support all EU24 languages? And clearly there are huge gaps even for speech-to-text for all EU24. And the specific examples usually include Irish or Maltese, which are much harder to support than higher resource languages. But ASR is one of those places where high quality data really matters. And let's quickly recognize that unlike written text, speech has also different challenges, including non-native speaker speech and different accents as well, and dialects. And so training models specific to a language spoken in a specific region, would that be different versions of German or different versions of French, basically constitute almost like a separate language on its own, unlike in the written form when machine translation engines are typically well trained to be able to do the work. But then again, not all languages are created equal, and I presented this graphic earlier this morning, but I want to bring it back to say there is a huge gap between how good generic speech recognition systems or speech-to-text systems can be in various languages. So there's really need to support equality across languages when we talk about the European Union. But the market is evolving, which is to say, previously, there were speech-to-text or ASR solutions. By now, we're in a place where they're built into conversational platforms and multimodal platforms, and they can be highly customized. The next one will be certainly that speech-to-text becomes a a built-in feature to and generally used in various applications and platforms. And there are a great many variables that can affect speech-to-text. I already talked about language, dialect, and accent, but also the channel or the environment, how noisy it is, what kind of recording device was used, how many people are speaking at the same time, how well they can be separated from each other as different channels. The topic of the vocabulary, they very much impact the outcome. So if this session, you're looking at the captions in WebEx, you might notice if I say alt-edic, then because the vocabulary was not fed into specifically into the custom trained engines, the transcription will not, or the caption, the transcription will not come out well, which is one of the reasons why at conferences, if a technology provider actually does speech-to-text or captioning services, automated captioning services, they pre-train the models that they use at those events. Those are not just some generic speech-to-text model that is being used. And of course, there are various integrations, would that be for right here into WebEx or other platforms that specifically define the niche in which providers can be successful. And this is exactly why ASR is a growing segment of the language technology market, from media and entertainment to conferencing, and even on live subtitles for social media and similar. They're very different environments, require different integrations. There are very different use cases that need custom solutions. Once, of course, the text is created, that everybody's happy and you can move on with machine translation. Not so fast though, because especially in live environments, it doesn't work so trivially. And of course, previously the way it worked was a speech-to-text or speech recognition solution. The way it worked was there was a kind of a language model built into the ASR solution and the vocabulary fed into it. The next version of it is rather these AI platforms or large language models, if you can still call them that. They include modalities for speech and vision and music and vision for images or even for videos as input. It's hard to call those large language models anymore. They're rather more generative AI platforms or language technology platforms. But the clear insight here is that integration into multimodal platforms of ASR solutions is already happening. The other side of the equation, of course, is when we need to convert text to speech, which is also a pretty big market. And AI dubbing is part of it, of course, probably a smaller version of it. But there are a lot of use cases for it. One of them is chatbots and conversational agents. And there's a lot of investment interest, and it's a very high growth potential market. And because the solutions that need to speak the language that is interesting and is captivating, triggers an emotional response from the listener, are not trivial to develop and to deploy in a customized manner for the individual customers and niches and segments. And of course, text-to-speech is also used in compound language technologies, whether it be in machine interpreting, AI avatars, speech-to-speech translation, and all of that, which are typically cascade systems. Moving on, here are some of the main actors. And again, you will find, yeah, this is also in many ways big technology and AI labs dominated. OpenAI is also here, but so is Amazon, Google, and even IBM or NVIDIA. But there are a lot of companies on this list who create, sometimes invisibly, these technologies. They offer them for sure. What underlying foundation model they use is sometimes obscured. That said, one of the key technology insights is often text-to-speech is considered an easier problem than the other way around, speech-to-text. But there are a lot of improvements that are actually needed when it comes to prosody or intonation or faithfully conveying emotional expression. And voice cloning, of course, is something that has come about already, but the emotional response is something that is still to be explored in many ways. And companies like 11 Labs or Voicey from Italy or Hume, which actually only provides English text-to-speech solutions at this point of time, they are at the forefront of providing more engaging and emotionally rich voices, synthetic voices. That said, synthetic voices are used, again, in compound solutions such as machine interpreting or speech-to-speech translation, which are, again, roughly a close to $1 billion euro market on their own. And the big difference between machine interpreting and speech-to-speech translation, if we can make this distinction, is that machine interpreting happens live, as well as there is an expectation that machine interpreting is what it is. It's interpreting. And it's important to make the distinction because the current systems, what they typically do is the machine speech translate, even live. And that's a big difference from what the job that interpreters do. And we don't say that the interpreters, they translate speech. They interpret. They rephrase, they paraphrase, they adjust the message for the listener from the original messenger. So the job is not directly comparable. But machine interpreting and speech-to-speech translation, they are finding new markets. As we see, there are, for machine interpreting, there are devices, in-person machine interpreting devices for consumers or tourism. There's a lot of software solutions, or quite a few software solutions that can be used for internal corporate communications. Even into WebEx, you could plug in a machine interpreting technology solution, or for e-learning or remote learning and training solutions. And then, of course, for speech translation, if you have the capability, then it can be used for marketing, PR agencies, and similar platforms. Next to that, some of the key actors, the three probably most prominent ones are Kudo, Interprefy, and Wordly. But let's very quickly know that the language coverage is, again, it's business opportunity limited, which is to say there's even a difference between source and target languages, source and output languages, rather, in machine interpreting. And typically high resource languages are the ones for which these systems are being developed. And importantly, just plugging together, you might think, a speech-to-text, a machine translation, and a text-to-speech system will result in machine interpreting. Well, that is certainly not so. There's a lot of added value by the machine interpreting actors in the entire data pipeline or textual and information pipeline orchestrated together with all the little delays and semantic modes to be understood so that the machine translation can actually produce reasonable outputs. And those few seconds of delay, they mean everything in the world of interpreting. So reducing those delays and latency is really important there. And Jourik, I think this is a good place that I call you in to say, for speech translation and all these speech language technologies, there is at least one highly complex use case that is worth elaborating. And using here an example from Dubformer and some insights, Jourik, if you can take over for a bit.
Yeah, so basically everything that you've been talking about is coming together on this slide. So the different speech-based technologies, speech-to-text, also machine translation, text-to-speech, if you put them together into one running workflow, that is still like the working paradigm for AI dubbing. There's a lot of interesting research going on in the field of speech-to-speech without the cascading, but it still doesn't work. It's not good enough in production. That's what I'm trying to say. And I had a talk with Dubformer a couple of weeks ago, and they were like, no, the cascaded workflow is still the way to go. And the cascaded workflow is also what transformed the speech technology market from a services market into a product market. It can be used already as a standalone product. It is increasingly being used for new media, YouTube videos, social media content, but also already for traditional media such as TV broadcast. So quickly elaborating on the process itself, it contains a lot of steps. The first step is intelligent transcription, intelligent speech to text, where the different speakers are recognized and where biometrical information is added to each speaker, gender, age, that kind of thing. The result of the transcription is translated using all bells and whistles, using neural machine translation, using LLM-driven post-editing, and a lot of other interesting things. The one thing that always catches my attention is when dubbing platforms say that translation isn't necessarily the biggest problem. That means something. After the translation, there's the voice casting. The AI dubbing platforms typically have a huge library of AI voices ready to be used off the shelf. Voice cloning is also well, a pretty common feature these days. And I've been told that voice cloning isn't necessarily the most difficult thing to do either. Maybe it's a little bit overhyped, but I of course acknowledge that in certain cases, educational content, documentaries, it's a very good thing. And then probably the most interesting thing is the fact that dubbing providers, AI dubbing providers, don't refer to text-to-speech as text-to-speech anymore. They now refer to it as neural speech synthesis, because converting text into speech, that is almost a solved problem. The differentiation lies elsewhere now. It's about transferring emotion. It's about transferring intonation. It's about duration loss, making sure that the translated speech matches the video content. It's about synchronization loss, making sure that the translated speech matches lip sync and pauses and all kinds of things in the video. That is the real differentiation. That's where business is being done right now. And then, of course, the last step is mixing everything back together, background noises, music, plus the translated speech, which is, well, again, this is the working paradigm in AI dubbing platforms today. Laszlo.
Thank you, Jourik. Thank you for the insights. And so we are completely technology impartial, and we pulled this out from Former just to illustrate some of the complexities under AI dubbing. But there are many other companies and initiatives that they do something very similar to different impact. And those include a lot of companies or startups with dub in their name, as well as companies like the big ones, AWS or Sony or Adobe are doing something similar. And very importantly, AI dubbing is kind of becoming part of everyday life as well. If you go to YouTube or Vimeo, you will find that there are AI dubbed content out there by now. Not just with voiceover, but literally dubbed from the original speech. And if you watch them, then you might notice, not long ago, I watched an Italian teacher. So I'm a mathematics and physics geek, and I watched him solve a physics problem with math on a blackboard with chalk, and it was AI dubbed. But the AI dubbing was not terribly good. It was automatically created, but I got the gist and I understood the problem solving and his thinking. So providing this kind of a support in understanding the communication, AI dubbing is already providing this value. But of course, you know, the Googles, the Metas, or ByteDance with TikTok, the reason why they're developing these, or even Adobe or Sony, is because they want to use AI dubbing in their own environments for their own content or for their own platforms. And next to it, of course, there are other providers as well who are creating solutions. Will be HeyGen or again 11 Labs, a voice changer can do something similar. And recently, we also learned something very interesting. A company called Crisp AI, they created an accent conversion technology, which kind of, especially in customer support environments, can reduce the accent almost real time of the speaker. So fortunately, I don't, but I could. I'm not sure if I could even try. But for example, a Hungarian accent when speaking English can be rather strong. And so this kind of technology, although it's currently limited only to a handful of languages, can help reduce the accent and make it more intelligible for other speakers. And there was even an example where it was the current American president was listening to a speaker from India and had to resort to an interpreter to understand what the Indian journalist's question was, because the accent was so strong that he couldn't understand it. These kind of technologies also could be supporting in those cases. But of course, AI dubbing is not just a standalone technology. Of course, all the dubbing providers are looking into adding AI dubbing into their portfolio, primarily because there is a market for AI dubbing where, again, just like machine translation is an alternative to no translation, or machine interpreting as a solution to no interpreting cases where there's no budget or there's no time for it. AI dubbing can also solve the problem for kind of the lower budget cases for documentaries or e-learning video content, corporate presentations, and similar places. And there are many challenges that need to be solved, as Jourik also mentioned, including conveying emotional messages, but also to a certain degree, aligning with the lip movements of the speaker, especially in high-value productions, is really important. So there are many challenges that still need to be solved, and we're looking forward to seeing these technologies develop further. Last but not least, a rather big, actually the second largest category of language technologies that we identified is chatbots and virtual assistants, conversational agents, which is a really big market because this is the language technology that supports user engagements, pre-sales, after-sales, customer support, and similar places. While previously most of the players or actors in the place, they use kind of rule-based, predefined conversations, which was a complete industry on its own. Conversation design for conversational agents. By now, large language models are providing a major disruption to this. So tools like AI avatars and all of these are being built into software platforms, software as a service platforms, and telecommunications or automotive, travel and hospitality, and all of those. And it's really a combination, similar to AI dubbing, a very complex use case for different language technologies. And there are many players in the space. Some of them offer essentially toolkits or platforms where a company can develop their own chatbot or assistant, and some of them will actually provide it for you and develop it for you. That's a major differentiation. But what we see is everywhere AI agents have disrupted the conversational design paradigm. And so even if just with voice or with video, with AI avatars, these new generation of chatbots, they are the new avenue to providing a 24/7 customer service. And there is very fierce competition here because as the language technology industry is generally global, it looks like many of these players could be competing against each other. But in creating these solutions, very often, again, the cultural proximity to the company, to the buyer, is really important to create the right solutions. So in Latvia, Tilde is probably in the best place to create Latvian chatbots, even though they could be built on Google's products, or almost any of these companies could build a product. But the proximity to understanding the client challenges, the language challenges, and the cultural aspects of chatbots is really important to creating the right solutions. All right, I think we got to the end of our slides, and we're coming to the end of today's conference, which in some sense, it's a very long segmented webinar, and I'm going to quickly look at the questions, if there are any. Oh, yes, there are. Agatha is very active in asking questions. Thank you for them. Do you have any data on countries' choice in general on subtitling versus dubbing? Yes, there is such data, and we didn't provide this in such data here in this report and presentations. But generally, yes, there are. We say in which countries or regions subtitling, dubbing, or even voiceovers as such are preferred. If I remember correctly, for example, in Russia, voiceovers are very strong. But generally, I think the notion is that, especially with Gen Z, subtitling is becoming really important. So instead of watching a dubbed version, reading the subtitles gives an additional input next to the visual input, and apparently Gen Z really enjoys this. So it's not just a question of countries and geographies, but also generations and perceptions of how multilingual value can be delivered in multimodal content. Off topic, I've seen glasses in China that provide live subtitles when speaking with someone. Yes, and wearable technologies also incorporate many language technologies. And it's not just the wearables, but the different hardware pieces as well. And would that be from whatever Meta's glasses or Google's new solutions? I would like to make a notion here where language technologies seem to be prevalent in many walks of life, but we also know of many, not necessarily failures, but massive challenges that come to implementing them, especially with devices and consumer use. And yes, this is a European Commission project. Yes, this is a conference primarily for Europeans given the time zone. But I would like to mention the fact that Apple, an American company, of course, they have been delaying the launch of their new large language model based Siri, their mobile phone assistant, for a while now. And apparently they say that it's not going to be launched till 2026 even, because they're not satisfied with how with its quality output. And that's to say, reiterating the notion that creating these integrations, language technologies into devices or software platforms is really easy. Getting the right output is really challenging. To make it high quality so that the users don't even perceive, just like, well, I don't know how the hardware works in my mobile phone. I don't want to know. I don't need to know. I just need to know it works every single time that I touch it. I turn it on, even if I speak to it with my voice. I don't want to know how the technology works underneath. That's the consumer mindset. And so creating these seamless experiences is not solved with language technologies in a great many of cases. I hope that answers the questions to a certain degree. Gonzalo asks, are TMS companies busy integrating these multimodal localization solutions into their available workflows? Is there demand? Good question. And the answer is yes and no. There is demand. There is demand to think about how to expand the translation management platforms to become this kind of language AI content platforms, whatever the ultimate name might be. The challenge is that developing these solutions in-house, even for technologically savvy translation management system companies, is really hard and takes a long time. So rather what they do is they literally integrate external providers, but they don't necessarily match, again, the traditional translation workflows. And so creating, again, the experience where in dubbing, the director or the engineer or even the language talent, the voice talent can go in and seamlessly take the content out from speech to text, put it into machine translation where somebody edits it or I edit it, and then put it back into text to speech and do the editing. It doesn't look like a single interface at this point of time, a challenge to be solved for the future. Do you have any idea how SEO might develop? So far, it has mainly focused on Google rankings. Wow, what a fantastic question! And we're about to write articles about this separately. It's a massive challenge that nobody really knows the answer to. The problem is that with AI search engines, would that be Perplexity or OpenAI Deep Research or similar, there is no well understood algorithm by which these tools pick the references that they use in their output. You could say, hey, Laszlo, but you don't really know how Google search algorithms work either. That's true, but there are many empirical ways through which that can be tested. A/B testing or similar is one way of doing this. We know, of course, that the AI search platforms, they also use some kind of search algorithms underneath the hood, but there's no traceability and directly debugging. There's no opportunity to look under the hood how references are created to websites, or even how producing the results in somebody visiting the website or not and looking for the real information. It's such a new technology and such a new interface that there's no real answer as to how SEO might be helpful, if at all, here, including the answer of multilingual search engine optimization, because large language models, at least to a certain degree, the way they work is mainly they work in English. Their internal language, if you will, is English. So if they see a multilingual website, they do the search, they might understand whatever French website. But will they prefer the English website over French because it's easier to read if the website is provided in both languages? What if the content is not the same on the website? And then in what language does the output come back from AI search? These are, at this point of time, unanswered questions that to be very honest, really complicates internet life as far as we can tell. And there's a lot of work and that needs to happen both on research and technology development, as well as generally the explainability of it. Ooh, many questions coming in. Do we have an estimated percentage of the take-up of LLMs within the EU companies and EU citizens? That's a really good question. And this market study was not created to answer that question specifically. There are various third-party researchers that try to answer this question for large language model uptake. Most of them specifically focus on enterprises, companies, and not individuals. Sampling individuals, of course, is possible, and it can be done even on country level or European Union level, and it's something that I would certainly encourage the European Union and the European Commission to do for the future, if that answers the question. Thank you, Nathanael, for asking it. All right. Ladies and gentlemen, we have the last 10 minutes of our conference, and I would like to hand back in a moment to Philippe Gelin for closing. I would like to make my closing remarks quickly before I say goodbye. Number one, this is the second conference following the Language Technology Landscape Conference of 2024, and it's been the Nimdzi team's pleasure to host you here. And again, the recording will be shared on the European Commission's YouTube channel, Digital EU, as well as the slides will be shared there too. And I would very much like to thank the European Commission for the opportunity to bring the insights from the market study at conferences like this. And I would like to say my heartfelt thanks to everybody on the Nimdzi team for participating and providing the research, the insight generation, and the report generation. It's amazing to have such a team behind. It looks like it's me, perhaps Josef, and Jourik as the individuals who are bringing those insights. There is a larger team behind who actually created it. So thank you to everybody for the participation. Philippe, can I hand the word back to you then?
Thank you, Laszlo. Thanks a lot for the presentation. As you have seen, the world of language technology is booming. Translation was pioneering, but application and service are booming a little bit everywhere. Huge investment has been seen. Most of the hype, I would say American hype, was to be first on the market, but technology is here to stay. LLM development cost is reducing, but it's still counteracted by the growing size of the model and the increased quality. And there is also the running cost of them. A translation model is 50 times smaller than an LLM and have also the same factor of running costs. So for some of the applications, smaller models are crucial to be used, basically, if only for the running cost exercise. Even though you've got new chip coming around, even on the edge, mobile chips to support the running of the AI exercise. In short, this domain has been transformative and is expected to keep being transformative for the years to come. The good news is that most of the breakthrough are scientific and available. They are, of course, company and trade secrets, but the main solution and advance are publicly available. We start to have tools to automatize the white-collar work, but it's going to be a long road, and as it has been with the translation. The tools help lowering the language barriers and reduce the localization cost, even if, as said Laszlo, human intervention is still essential to ensure trust. But one thing is sure, data is key in this process. Going back to data, we all see a trend. Data not for LLM training, but for LLM adaptation and or tuning, fine-tuning, we see really an increase and a creation of a market there. The value of them are smaller, but high-quality data sets, the concept of data stream and licensing data access. We believe it's going to be a very interesting field to watch, and the language data space, which ultimately is really to build a private angle of sharing data, so really making a market of data, is arriving at maturity, and we hope that it will be useful to really deploy this data market exercise. That being said, I really thank you all for your participation and the interesting questions. I hope you found interesting information and wish you all an excellent afternoon. Thanks a lot, everybody.